Hi, welcome to Bits and Proofs. Today we are going to build an MCP server in Python. The Model Context Protocol is how AI agents, Claude Desktop, Gemini Desktop, ChatGPT, and others connect to your files, your databases, and your APIs. We will write a working server in 10 minutes. Imagine for a second that you could ask Claude or any AI agent to look at the notes you actually have on your machine, not training data, your real current notes. Or query your team's database to answer a question, or trigger a CI pipeline because you said the word deploy, or look at your calendar before scheduling something for you. The protocol is called MCP, Model Context Protocol. We are going to build an MCP server in less than 20 lines of code. First, what MCP actually is. The shortest answer, MCP is USB-C for AI tooling. One server, any AI agent, write it once and Claude Desktop, Gemini Desktop, ChatGPT, and the others can all use it. The protocol is open. Anthropic released it under a permissive license at the end of 2024, and the ecosystem has grown quickly since. Every MCP server can expose three kinds of things: tools, functions that the model can call, resources, data that the model can read, and prompts, reusable templates the model can fill in. Today we focus on tools because tools are where most of the value is, and they are the easiest to demonstrate. Once you understand one tool, adding more is the same pattern repeated. So let's build the first one. Here is what actually happens when an AI agent uses your tool. Let's walk through the full round trip. First, the forward flow, 5 steps from prompt to data. Step 1, the user gives the AI agent a prompt in plain language. For example, what notes do I have? The AI agent is the program you actually interact with, like Claude, Gemini, ChatGPT, or any application that speaks MCP. Step 2, the AI agent asks the LLM, the language model, what to do. The LLM is the brain. It does not touch your files, it just figures out what to do next. Step 3, the LLM tells the AI agent to call your MCP server. Step 4, the AI agent makes the tool call to your Python script. Step 5, your script fetches the data from files, databases, APIs. Now the response flows back. Step 6, your data layer returns the result to your MCP server. Step 7, the server passes it back to the agent. Step 8, the agent forwards it to the LLM with the original question for context. Step 9, the LLM turns the raw data into a natural language response. Step 10, the agent delivers that final response to the user. That is the whole round trip. Let's understand what the conversation actually looks like. When the agent decides to use your tool, it sends a JSON message that says, call this tool named list_notes with these arguments. In this example, no arguments. Your server runs the function and responds with a JSON message containing the result. In this case, the 3 file names it found. That is the entire protocol. JSON-RPC version 2, a two-way conversation. The agent calls your tools. Your server can also push notifications back asynchronously. For instance, when your tool list changes, so the agent picks up new tools without restarting. The transport is standard input and output for local servers, or HTTP for remote ones. The Python SDK handles all the wiring. You just write a Python function with a doc string. Let me show you. The setup is one command: pip install MCP. That is the official Python SDK from Anthropic. It is open source and well documented. Then create a file. Call it notes_server.py, and we are ready to write our server. Here is the function we want to expose to the agent. A plain Python function. It looks in your notes folder, gathers the markdown files, and returns them as a new line separated list. Nothing MCP specific yet, just Python you could have written before this video. Now we add the MCP wiring. First, import fastMCP from the SDK, that is the high-level builder class from the MCP Python package. We also import os and pathlib for the file system work. Next, create the server. The name notes is just a label. It shows up in the agent's tool list so the user can see what kind of server it is. Now the key line, the @mcp.tool decorator turns any Python function into a tool the agent can call. The function name becomes the tool name. The return type tells the protocol the shape of the response. And here is the important part. The docstring becomes the tool's description. That is the text the agent reads to decide when and how to call it. Write it like a hint for a smart colleague. And the bottom of the file, if this script is run directly, start the server. mcp.run handles the standard input loop, the JSON parsing, the response formatting. You do not see any of that. You just write Python. Let's add a second tool, reading a specific note. Same idea, start with a plain Python function. It takes the file name, builds the path inside your notes folder, and returns the contents, or an error if the file does not exist. Now make it a tool. Add mcp.tool above the function. That is all you need. The function name becomes the tool name. The argument name and type become the tool's parameter schema. The docstring becomes the description. The agent sees a tool called read_note with one parameter, name, expected as a string. It figures out the rest. You did not have to teach it. The agent decides on its own when to call this tool. If the user says, read me my to-do note, the agent recognizes that name should be todo.md and calls it. And the return value flows right back into the model's context. The text becomes part of the conversation. From the user's perspective, the agent just knows. Now connect this to a real AI agent. We will use Claude Desktop. Open the config file. The path depends on your operating system. On macOS, it lives under Library Application Support Claude. On Windows, under App Data Claude. On Linux, under .config Claude. The fill name is the same on all three, Claude_desktop_config.json. Add an entry under MCP servers. Give your server a name. I am calling it notes. Tell it what command to run, Python, and the full path to your script. Restart Claude Desktop. The next time the app launches, it will find your config, launch your server, ask it what tools it provides, and tell the model, these are now available for you. You wrote the server once. Other MCP clients can use it too, but it is worth knowing how each one reaches your server because the differences matter. ChatGPT supports MCP through its apps and connectors settings. The important detail, ChatGPT only talks to remote MCP servers. That means your server has to be hosted somewhere reachable over HTTP with a public URL. The Nodes server we just wrote running on your laptop will not work for ChatGPT directly. You would need to deploy it first. Cursor has an MCP settings panel. By default, it launches your server locally, the same JSON shape Claude Desktop uses. Same standard input-output transport. Cursor also supports remote HTTP servers if you need them. Cline is a VS code extension. It edits a similar JSON file in its extension data folder, launches your server locally, and adds a small marketplace UI for installing community servers. Local subprocess model, same as Claude Desktop. OpenCode is a terminal-first coding agent, no graphical interface, runs in your shell. You add servers under an MCP entry in its OpenCode.json config. Local subprocess again, same protocol. Google's Gemini CLE and Gemini Code Assist read an MCP server's block in their settings file. Same local STD model, same JSON shape, just a different config path. So the split that matters, ChatGPT goes through remote HTTP hosted servers. Claude Desktop, Cursor, Cline, OpenCode, and Gemini all launch your script as a local subprocess on your own machine. Both are MCP, but the deployment story is different. For something that touches your personal files, local is usually what you want. I have linked the official setup docs for every agent shown here in the video description below. And it works. The user asks, what notes do I have? Claude sees the question, recognizes that the list notes tool can answer it, and calls it. Behind the scenes, your Python function ran on your machine. The return value came back as JSON through standard input and output. Claude then formats it into a natural reply. From the user's perspective, the assistant just knows. From your perspective, your code ran. That is the entire integration loop. Now think about what this opens up. Personal automation, notes, tasks, calendar, browser history, your own scripts. Anything sitting on your machine that you can reach from Python becomes context the AI can use. Internal company tools. Wrap your database. Wrap your ticketing system. Wrap your deployment pipeline. Suddenly, the AI understands your business in a way it could never understand from training data alone. Real-time data, stock prices, weather, service health metrics, deployment status, anything that changes after the model was trained. And side effects, tools that do things, not just read. Sending an email, posting a message, triggering a build. The model becomes capable of acting, not just answering. This is where assistants stop being chatbots and start being colleagues. You don't have to build everything yourself. A lot of useful servers already exist. Filesystem servers for reading and writing files on your machine. GitHub servers for pull requests and issue search. Postgres servers for running queries on your database. Slack servers for searching and posting messages. Browser servers for controlling Chrome, clicking, scrolling, filling forms. All of these are open source, available on the official MCP servers registry and growing every week. The protocol is well designed and stays out of your way. Let me put MCP in context. MCP is the tooling layer of AI engineering. The model is one piece. The context window is another. The tools, what the model can actually do, are how you build real applications that integrate with the world. Where to go from here? First, try wrapping an API you already use. The mechanics are exactly what we did today, just with HTTP calls inside your tool functions. Second, explore resources and prompts, the other two primitives MCP offers. And third, start composing your tools into real workflows. One last thing before we close out. MCP is powerful, and that is the point of this warning slide. The model decides when to call your tools. You do not get to pre-approve every invocation the way you would with a normal function call in your own code. Principle 1, least privilege. If a tool only needs to read, do not give it write. Delete and overwrite operations should require an explicit confirmation step built into the tool itself, not the model's judgment. Principle 2, never put secrets in tool return values. Anything you return becomes part of the model's context. It can end up in a later reply, a log file, or someone's screenshot. Treat the return channel as public. Principle 3, treat third-party servers as untrusted. A malicious MCP server can prompt inject the model through the data it returns. If you are installing a community server, read the source first, especially for servers that touch your file system, your shell, or anything that can call out to the internet. Principle 4, log what gets called. When something surprising happens, and at some point it will, you will want to know which tool fired off, with which arguments, and when. Future, you will thank Present You for the audit trail. Thanks for watching. If this helped you, hit subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.